Question 1. A sample space consists of 4 separate outcomes that are equally likely. What is the probability of each? Well, the number of outcomes in the sample space is 14. There are 14 distinct different outcomes, so the probability of an event or an outcome for the sample space is 1 over 14. Each is equally likely. Question 3. A bag contains 2 red marbles, 3 blue marbles, and 5 green marbles, for a total of 10 marbles. There's 10 marbles in the bag. If a marble is randomly selected from the bag, what's the probability that it's blue? Probability of selecting a blue marble is found by determining the number of marbles that are blue divided by the total number of possible marbles, which is 3 over 10. This is your answer. Question 5. A class consists of 49 women and 92 men. Notice that this means there are 141 students in the class. If a student is randomly selected, what is the probability that the student is a woman? Probably the student's woman is found by determining the number of women in the class divided by the total number of students. There are 49 women out of 141 students. This is your answer. Question 7. You're going to toss a coin twice. We have to determine the sample space associated with tossing a coin twice. We're going to draw a tree diagram. So in the first toss, you have 2 possible outcomes, either a heads or a tails. This is for the first toss. Now, if the first toss was a heads, on the second toss, you have again either a heads or a tails for the second toss. If the first toss was a tails, on the second toss, again, it'll either be a heads or a tails. So if you follow the branches on this tree, you'll see HH, HT, TH, and TT. This is the list of all possible outcomes associated with tossing a coin twice. Question 9. Frisky is having her 5th litter. The prior litters have either been 3 normal pups or 2 normal pups and a runt. Assume the probability of either event is 0.50. The problem is easier than it sounds. So the likelihood is 50-50 or 0.5. It could be either 3 normal pups, N, or 2 normal pups, N, and a runt. These 2 outcomes form your sample space. Question 11. Is a genetic problem between mice. A male has both white and black fur color gene. So this is where the male is going to be. The female has two white color genes. This is a female. So we're going to take a look at what occurs in terms of the genes of their offspring. The male and female, when they have an offspring, contribute one genotype, which is W for the male, W for the female. W for a male, W from the female. W from the female, B from the male, W from the female, B from the male. So that what we see here is a list of all possible outcomes in terms of the genes for offspring. In a certain class, there are 8 boys from Wilmette, 6 girls from Kenilworth, 8 girls from Wilmette, 7 boys from Glencoe, 3 boys from Kenilworth, and 6 girls from Glencoe. If the teacher calls upon a student to answer the question, what's the probability that the student will be from Kenilworth? Well, let's keep track of the sex of the class and their location. So, we're going to keep track of boys and girls. The first location looks to be Wilmette, in which there is 8 boys. Six girls are from Kenilworth. 8 girls are from Wilmette. 7 boys are from Glencoe. 3 boys are from Kenilworth. And 6 girls are from Glencoe. So notice this means there's a total of 18 boys, 22 girls, so we can say that there are 40 students. 16 will be from Wilmette, 9 will be from Kenilworth, 13 will be from Glencoe. So the question is, if a teacher calls upon a student to answer a question, what is the probability that the student will be from Kenilworth? Probability you're from Kenilworth, well, there's 9 students from Kenilworth out of a total of 40. So the answer is 9 over 40. Question 15. Draw a tree diagram to find the number of possible outcomes. Question 15 says, toss a single die and then toss a coin. So we're first going to toss a die and then toss a coin. Well, 2, 3. 1, 2, 3, 4, 5, 6. These are the outcomes associated with rolling a die. Now we're now going to toss a coin, in which every outcome on the die roll can have a possible heads or tail outcome for the coin toss. So if we follow the branches, we'll see 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5t, 6h, and 6t. This is a list of all possible outcomes associated with rolling a die and then tossing a coin. Question 17. Toss two coins. I'm going to toss two coins now. The first coin toss can be a heads or a tail. The second can be a heads or a tail. If the first was a heads, it could be a heads or a tail if the first were a tail. So following the branches, we get the list of all possible outcomes. Question 19. You roll a die. If you roll a die, the question is, what's the probability of landing on a 4? Well, that's found by determining the number of outcomes associated with landing on a 4 divided by the total number of possible outcomes. When you roll a die, you can roll a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 outcomes in the sample space. Well, the event of rolling a 4 consists of the single outcome of a 4. Therefore, the probability is 1 over 6. One outcome consists of the 4 out of the 6 possible outcomes. Question 21. If a single die is tossed once, find the probability that it will be an even number. Again, we'll roll a die. The sample space was a list of outcomes of 1 through 6. Now, I'll let E be the event of rolling an even number. These are the even numbers in our sample space. So the probability that you roll an even number is the number of outcomes associated with rolling an even number, which is 3, divided by the total number of possible outcomes, which is 6. You can reduce this fraction to 1/2, which is your answer. Question 23. A bag contains 8 red marbles, 6 blue marbles, 2 yellow, and 3 green. 8 red, 6 blue, 2 yellow, 3 green. Notice this becomes 19 marbles. 19 marbles are in your bag. What is the probability of choosing a red marble? The probability of choosing a red marble is found by determining the number of red marbles in the bag divided by the total number of possible marbles. Since there are 8 marbles that are red out of 19, the answer is 8 over 19. Question 25. A bag contains 15 balls numbered 1 through 15. What is the probability of selecting a ball that is even? The sample space consists of balls that are numbered 1 through 15. If we look at the sample space and remove the outcomes that are even, 2, 4, 6, 8, 10, 12, and 14, we could deduce the probability of selecting an even number. That's the number of even numbers that are in this bag, which is 1, 2, 3, 4, 5, 6, 7, divided by the total number of possible numbers that are in the bag. There's 15 numbers. The probability is 7 to